Are you struggling to format timestamps in Java 8 with optional milliseconds, microseconds, or even nanoseconds? You're not alone. Today, we're diving into how to create a date-time formatter that meets your needs. I totally get it. Formatting timestamps can be tricky, especially when you want to include different levels of precision. Many developers face this challenge, and it can be frustrating when things don't work as expected. Here's the specific question we're addressing today. One user asked how to create a formatter for parsing timestamps with optional fractions of a second, specifically allowing for 3, 6, or 9 digits after the decimal point. Sound familiar? Let's explore this together. To understand the issue, we need to look at how Java's DateTimeFormatter works. It allows for flexible formatting, but getting it to parse specific fractional seconds can be a bit complex. We'll break it down step by step. And stick around. At the end of this video, I'll share a pro tip that will make your timestamp formatting even easier. To create a DateTime formatter that can parse timestamps with optional milliseconds, microseconds, or nanoseconds, the user should start by using the DateTimeFormatter builder class. Next, the user needs to append the basic ISO date format and the local time format to the builder. This will set up the structure for the timestamp. Now, the user should append the optional fraction of seconds. This is done using the append fraction method, specifying the field and the minimum and maximum widths. Finally, the user should append the offset and build the formatter. This will complete the setup for parsing the desired timestamp formats. With this setup, the user can now parse timestamps like hours, minutes, seconds, and the optional fractions of seconds, ensuring that only 3, 6, or 9 digits are accepted. Fun fact, did you know that the concept of time zones was only introduced in the late 19th century? Before that, every city had its own local time. Now let's look at the answers provided by other users. An alternative approach suggests that since DateTimeFormatter only supports width ranges, you can create 3 separate formatters for parsing. Each formatter would handle 3, 6, or 9 fractional digits. You would attempt to parse the input with each formatter in sequence, catching any parsing exceptions until the last one. Another option is to check the input format using a regular expression before parsing. This can help ensure that the input matches the expected patterns for 3, 6, or 9 fractional digits. Here's the pro tip I promised. Always test your DateTime formatter with various timestamp formats to ensure it behaves as expected. This will save you a lot of headaches down the line. And there you have it. You now know how to create a DateTime formatter that can handle optional milliseconds, microseconds, or nanoseconds. If you found this video helpful, please subscribe for more programming tips and tricks.